Most people charge their phones the same way they've always done, and most are shortening their battery's lifespan without realizing it. If you let your phone die before plugging it in, or if you always charge to 100% overnight, you're doing exactly what lithium-ion batteries hate most. Before we dive into why, drop a comment with your name and city. We love knowing where our viewers are watching from. Here's what you'll learn today: how your phone battery actually works at the chemical level, why common charging habits damage it, and the exact strategy battery engineers recommend to keep your battery healthy for years. Let's start with what happens inside that slim rectangle every time you plug in your charger. Your phone uses a lithium-ion battery, and the name tells you the key player, lithium ions. These are atoms that lost one electron, giving them a positive charge. Inside the battery you have two electrodes, the anode made of graphite and the cathode made of lithium metal oxide. Between them sits an electrolyte, a liquid that lets ions move but blocks electrons. When you use your phone, lithium ions flow from the anode through the electrolyte to the cathode. Electrons can't follow that path, so they're forced to travel through your phone circuits instead, powering the screen, processor, and everything else. When you charge, you reverse this. The charger pushes electrons backward through the circuit, and that electrical pressure drives lithium ions back from the cathode into the anode's graphite layers. The anode is like a sliced cake. Graphite has flat sheets of carbon atoms, and lithium ions slide between these sheets, a process called intercalation. Here's the critical part. This process isn't perfectly reversible. Every charge cycle causes tiny amounts of lithium to get stuck, forming compounds that don't participate in future cycles. The electrolyte also breaks down slowly, creating a solid layer on the anode surface called the SEI, solid electrolyte interphase. This layer is necessary for the battery to work, but it grows thicker over time, increasing resistance and eating up lithium. After 500 full cycles, a typical battery loses about 20% of its original capacity. Now, why does charging to 100% hurt your battery? It comes down to voltage stress. When your battery is full, the voltage across the electrodes is at its maximum, around 4.2 volts for most phone batteries. At this high voltage, the electrolyte becomes more reactive, breaking down faster and thickening that SEI layer. The cathode also becomes less stable. Lithium cobalt oxide, a common cathode material, can release oxygen at high voltages, and that oxygen attacks the electrolyte. The longer your battery sits at full charge, the more this degradation happens. Charging to 100% and leaving it plugged in overnight means 8 hours at maximum voltage stress. Battery researchers have measured this. A lithium-ion cell kept at 100% charge and room temperature loses about 20% capacity in 1 year. The same cell kept at 50% charge loses only 4%. The difference is huge. On the opposite end, letting your battery fully discharge also causes damage, but for a different reason. When the battery voltage drops too low, copper from the current collector inside the anode can dissolve into the electrolyte. When you recharge, this copper can plate out as metal dendrites, tiny spikes that grow toward the cathode. If a dendrite bridges the gap, it creates an internal short circuit, which can lead to thermal runaway. Modern phones have protection circuits that cut off power before true 0 volts, usually stopping discharge around 3.0 volts when the indicator shows 0%. But even this isn't the ideal bottom limit. Deep discharges stress the cathode structure. Removing almost all the lithium ions from the cathode causes the crystal lattice to contract significantly. When you recharge and ions flood back in, the lattice expands again. This repeated expansion and contraction creates micro cracks in the cathode particles, increasing resistance and reducing capacity over time. So what's the solution? Battery engineers recommend keeping your phone between 20 and 80% charge as much as possible. This range keeps voltage stress moderate and avoids deep cathode contraction. Some manufacturers now build this into their software. Optimized charging features learn your routine and delay charging past 80% until just before you wake up, minimizing time at full charge. The chemistry behind this is called the voltage versus state of charge curve. It's not linear. Going from 0 to 50% involves a smaller voltage change than going from 50 to 100. That last 20% from 80 to full pushes voltage into the zone where degradation accelerates. If you need full charge for a long day, that's fine occasionally. The damage is cumulative, not instant. But if you're home with access to a charger, topping up to 80% twice is better than one full charge to 100. Heat is another enemy. Chemical reactions double in speed for every 10 degrees Celsius increase in temperature, a rule called the Arrhenius equation. When your phone gets hot while charging, all those degradation reactions, electrolyte breakdown, SEI growth, cathode oxygen release, happen faster. Avoid charging in hot environments. Don't leave your phone in a car on a sunny day while plugged in, and remove thick cases during charging if your phone runs warm. Fast charging adds heat because higher current means more resistive heating. The battery has internal resistance, and when you push more amps through it, power is lost as heat. The formula is simple. Heat equals current squared times resistance. Double the current, and you quadruple the heat. That's why a 30-watt fast charger warms your phone more than a 5-watt standard charger. Fast charging also accelerates a process called lithium plating. At high charge rates, lithium ions arrive at the anode faster than they can intercalate into the graphite. Some plate onto the anode surface as metallic lithium instead of sliding between the graphene layers. This plated lithium is lost capacity, and it's also a safety risk since lithium metal is reactive. Phone makers know this, so fast charging tapers off as the battery fills. If you watch the charging curve, you'll see the first 50% charges quickly, but the last 20% slows down significantly. This taper reduces current when the battery is most vulnerable. Here's a practical habit. Charge your phone when convenient, not when necessary. If you're at your desk and the battery is at 40%, plugging it in for 30 minutes won't hurt. You don't need to wait for a low battery warning. Frequent shallow charges create less stress than infrequent deep cycles. The idea that you should fully cycle your battery comes from old nickel-cadmium batteries which had memory effect. Lithium-ion batteries don't have this problem. In fact, they prefer partial cycles. One charge from 30 to 70% counts as 0.4 of a cycle, not a full one. You could do this 1,000 times and only log 400 cycles. Wireless charging is convenient but generates more heat than wired charging due to efficiency losses in the induction coil. About 20 to 30% of the energy is lost as heat in the charging pad and phone coil. If your phone feels warm on a wireless charger, that heat is aging your battery faster. For overnight charging, wired is better. Using your phone while charging doesn't directly harm the battery, but it generates additional heat from the processor and screen. If you're gaming while fast charging, you're combining two heat sources, and that accelerates aging. Modern lithium-ion batteries are good for about 500 to 800 full cycles before dropping to 80% capacity. With the 20 to 80 habit, you extend this significantly because each charge is a fraction of a cycle. A phone used this way can easily last 3 to 4 years before battery replacement becomes necessary. To sum up the strategy battery scientists recommend, keep your charge between 20 and 80% most of the time. Avoid heat during charging, use optimized charging features if your phone has them, and don't stress about plugging in whenever it's convenient. These habits align with the chemistry of lithium-ion cells and will keep your battery healthier longer. If you found this useful, subscribe so you don't miss our next deep dive. And drop another comment. Tell us where you're watching from and if you've been doing any of these charging mistakes. We'll be breaking down more tech that affects your daily life.